So for section 2.2 polynomial functions, our first part we're going to go over what we call leading term tests. So what I mean by leading term is the leading degree and the leading coefficient. So up here is this chart that reference to 1.3 in behavior. So basically we're going to use the information that's given out. Now you don't have to copy this because you already have it in 1.3. All we're doing is now we are using it again and applying to leading term tests. So when it comes to leading term tests, our first job is to identify leading degree. So leading degree, LD, meaning highest degree. So we have degree is exponent, so 2, 5, 6, and invisible 1. So our leading degree is our highest. So this one right here, out of all four, 6 is the highest. So I'm going to underline saying that this is our highest. Next, you have to identify your leading coefficient. Leading coefficient is the number or the sign of the number with the leading degree. That's why it's called leading coefficient. So our leading coefficient is right here. The number or the sign of the number with the leading degree. So what I'm going to do is I'm going to write out the leading degree and leading coefficient. So that way I show out what I know in case I'm doing this on a test. So my LD leading degree is 6, which is right there. And then my leading coefficient. Now we don't have to put a number. All we have to do is just put if it's positive or negative, just like right here. LC plus for positive, and then LC equal to minus for negative. So we look at this one, it's a plus 4, so it's positive. So all I have to do is just write plus. Just plus. That's all we have to do. LD is 6, and then LC is positive because of that plus right there. Now, back to what we did before is the limit notation. So we have the right side and the left side. So you actually have to do both. So if I'm just asking for leading term test for this function, you have to do two limits. One for the right side, one for the left side. So let's do the right side first. So the limit of f of x, and the reason I use f of x because of this one right there. For the right side, meaning x approaches to infinity. Now, let's take a look. Leading degree, it's even, so we're going to go on this section. It's positive, so I'm going to look at this column right here. So even, this side, and then positive, I look at this column. So the limit of f of x as x approaches to infinity, this column, so I'm going to be writing this over here. Now we just do the left side. So the limit of f of x as x approaches to negative infinity, the left side, equal, so again, going back to this side for even, then this column for positive. So my left side is this. So again, left side will equal to this. So I'm going to write infinity. So my right side, even, positive, I got it right here. And then my left side, so even, positive, here's my left side, I got it right there. So again, when we're using leading term test, find leading degree, tell me if it's positive or negative, and then you use the information to give out the answer here. Okay? So again, all you have to do is just write the limit notation for both sides. So the right side and then the left side, or vice versa, doesn't matter to me, as long as you write it correctly and then make sure they match up. Again, I got it from here for right side, and I got it right here for left side. Now we have our second example, f of x equals negative x to the third plus 6x to the fourth minus 3x to the fifth plus 2x squared. Now keep in mind, in the last example, in this one, the exponents are not in order from highest to least. So I want you to get into the habit of, just in case, if it's not in order, you should be able to identify your leading degree, or also known as highest degree. So let's take a look. 3, 4, 5, 2. Those are our exponents. So right here, our highest of all them 4 is 5. So that means I'm going to be looking at the leading coefficient here too. So let's take a look. Leading degree is 5. And then the leading coefficient, since it's minus, is going to be negative. So that means that since it's odd, we're going to look at this section for leading degree of odd. Then leading coefficient is negative, so we're going to look at this column right here. So let's start off with our limit notation, our in behavior. So I'm going to write limit of f of x. Again, I'm using f of x because they use f of x. As x approach to infinity, the right side. So odd for leading degree, and then leading coefficient negative. So our right side is what this is going to equal to, negative infinity. So I'm going to write negative infinity. Now I'm going to do the left side. Limit of f of x as x approach to negative infinity. Again, this is left side, that's right side. So again, odd side, leading degree of odd side, negative for leading coefficient. So I'm doing the left side. So I'm looking at here. So the left side is this. So left side is this. So infinity. So again, to review, odd degree, negative leading coefficient. So we're going to look at these two right here. So the right side equal to negative infinity. The left side right here equals to positive infinity, or just infinity. So here our two limit notation for in behavior. The right side and the left side. So again, it does not matter the order. You could do left side first and then right side. But as long as you write correctly, make sure the in behavior matches with the correct sides. For our third example, we have m of x equals negative 7x to the fourth plus 3x to the fifth plus 4x squared minus 2x to the eighth. So again, we have to find our leading degree. So our exponent is 4, 5, 2, and 8. So out of the 4, 8 is the highest, so it's back here. So that means we have to look at this leading coefficient. So our leading degree is 8. And then we take a look, it's minus 2, so that means it's negative. So we're going to be looking at the even side for leading degree, and then we're going to look at the negative for the leading coefficient. So we got the information. We got the information for the right side and the left side. So now we just got to write the limit notation for in behavior. So let's say for this time I'm doing the left side first. So we're going to do limit of m of x. So again, I'm using m of x because that's what they use. Limit of m of x as x approach to negative infinity. We're doing the left side first. So as x approach to negative infinity, here's the left side. Here's the even and leading negative leading coefficient. So left side is this. Alright, so now let's do the right side. So the limit of m of x as x approach to infinity. So we're doing the right side. Same column, even negative leading coefficient. The right side is this. So this is the right side. and this is what it's going to equal to. So negative infinity. So both of them are equal to negative infinity. This is the left side. Now this is the right side. So again, for this function, the leading degree is 8. Leading coefficient is negative, so we're going to look at this column. Here's the right side, which is right here. And then here is the left side, which is right there. So again, I start off with the left side and end it with the right side. Order does not matter. As long as you correctly write the sides and it's corresponding in behavior. So left side, right side.